as you get ready for the test and you go through this practice test, every time you get a question that you perhaps don't know what to do right away, or maybe you're just thinking about it, I want you to ask yourself, where have I seen those instructions before, like find all zeros of p of x? Here we have a polynomial function, and just recently we learned how to graph polynomial functions that look like this when they're in factored form, and we took the factored form and we found the zeros. So finding the zeros for a polynomial function that's in factored form is easy as long as you understand that the connection between, okay, we have a factor of x plus 3, therefore the zeros are, one of them is negative 3, because negative 3 plus 3 is 0. If a real number makes a factor equal to 0, then it's a 0, because anytime if we replace x with negative 3 here, negative 3 plus 3 is 0, it makes that factor 0, and no matter what these other factors are, 0 times anything is just going to be 0. So negative 3 makes that factor 0, 1 makes that factor 0, and then what number makes this factor 0? 5 minus 5 is 0. So we have the zeros, and once we have the zeros, we graph them, negative 3, 1, and then 5. So we would plot the points on the x-axis, and then we would proceed to graph the function. But those are the zeros, negative 3, 1, and 5. Well, over here, we're still asked to find the zeros, but clearly the function here is not in factored form. And so when I ask you to start thinking about, well, when have I ever had to do that? Well, you had to do this when you had factored form, and it was easy when you're in factored form to find the zeros. Well, you're not in factored form, and the missing link here is you need to be in factored form in order to find the zeros. So that's the whole point. We have to be in factored form. So if you're having trouble factoring, well, that's another issue. But I'm going to assume in this video that you know how to factor that. Running through the 3 types of factoring, if it's the first thing we always look for is there a GCF, greatest common factor? And in fact, there's an x squared that is a common factor to all 3 terms. And there are no other common factors. Once we factor out x squared from 2x to the 4th, we're left with 2 times x squared. When we factor out an x squared from negative 3x cubed, we have minus 3x, and then factoring out an x squared from the negative 8x squared, we just are left with minus 8. Now, after factoring out, I should say, the x squared, we notice that we have a trinomial. Well, we've already exhausted our greatest common factor, and then we run down, well, we have to factor the remaining polynomial. Do we have a difference of squares? Well, of course we don't have a difference of squares, because to have a difference of squares, you have to have a difference between 2 things, and both of those things are perfect squares. Well, you have to have 2 terms for that. So 2, dos means 2 in Spanish, and then so we don't have 2 terms, we have 3 terms. And so when we have 3 terms, we look at the FOIL method. And so the only way outside of greatest common factor that a trinomial, a 3-term polynomial, can be factored when it's in standard form is by using the FOIL method. The only way. And so to do that, we want to find the factors of 2x squared. I don't even know if this factors. I'm just trying to factor it. 2x times x is 2x squared. Then we have to find factors of 8 that we can put in here. And we can't use the 2 and the 4 because both of those are even numbers. We can't put a 2 or a 4 right there because it would be in the same set of parentheses as another even number. And we can't have 2 even numbers in the same set of parentheses after we've already factored out a GCF. So therefore, we have 1 and 8 only. And so since we have 1 and 8 only, I'm looking at this thinking it was going to factor, but it actually doesn't factor. If we put an 8 there and a 1 there, then we're going to get 16x and 1x, and that's not going to add up to negative 3x. So this will not factor. However, if we finding the zeros, we have to figure out what x values that polynomial is equal to 0, and we do that by by using the quadratic formula. So this became a harder problem than I thought it was going to be, more involved anyway. If we set this equal to 0, clearly if x squared equals 0, then x equals 0. But if this polynomial, quadratic polynomial, is equal to 0, it means that x has to equal, setting it equal to 0, x has to equal the opposite of b plus or minus the square root of b squared, it's negative 3 squared, minus 4 times a, which is 2, and I got to squeeze this in here, times c, which is negative 8. Sorry about that. And then over 2 times a. And so cleaning this up a little bit, the opposite of negative 3 is positive 3, plus or minus the square root of negative 3 squared is 9. And then we have a negative and a negative. That's going to be a positive. 4 times 2 is 8. 8 times 8 is 64. All over 2 times 2 is 4. So I'm kind of glad that we don't have any more simplifying to do after we add the 9 and the 64 to 73. So that simplifies completely. And so x equals 3 plus or minus radical 73 over 4. We can't reduce radical 73 any. 7 doesn't go into it. 2, 3, 4, 5, 6, 8, 7, 8, 9, 10, 11, 12, 13. 13 goes into 65, so it doesn't go into 73. Once I get past 13, I'm good. I don't want to try anymore. So that means that those two numbers are zeros, and so is x equals 0. So we have two zeros, 0 and 3 plus or minus radical 73 over 4.